We're moving along to number 3, and 3a looks a little something like this. X squared minus 7x plus 10 equals 0, so it is unfactored. You'll notice as we look at Desmos that we graphed this quadratic and that it hits at 2 zeros. One of them is right here at 2. The other one is at 5. So we know those are going to be our solutions. Where do those solutions come from? Well, we have a trinomial. And this trinomial factors so that we know that our first two terms have to be x and x. We know that our last two terms have to be 10 multiplied to positive 10, and they have to add up to a negative 7. So I'm thinking that our only options are negative 1 and negative 10, or negative 2 and negative 5, because those are the only two pairs that will give us positive 10. Notice that this is the pair that adds up to negative 7. So negative 2 here, negative 5 here, and our solutions are going to be x equals 2, x equals 5. Moving along to the next one. So A was a simpler example because the leading coefficient was 1. On B, our leading coefficient is not 1, and that does complicate things a little bit. So here's what we know. We know that the first two terms, here and here, have to multiply to give us a 3x squared. So 3x and x. We know that our last two terms have to multiply to give us a negative 4. So we've got a bunch of options. It could be a 1 and negative 4. It could be a negative 1 and a positive 4. It could be a 2 and a negative 2. So you need to decide which one goes where, keeping in mind that the outer terms and the inner terms have to add up to a positive 11. So you might have to play around with it a little bit, but eventually you'll arrive at this. If we put a 4 here and a negative 1 here, now our outer terms add up to 12, and our inner terms add up to negative x. So that's 12x plus negative x is the 11x that we're looking for. Okay. So our solutions are going to be set 3x minus 1 equal to 0, and you'll get x equals 1/3. Set x plus 4 equal to 0, and you'll get x is equal to negative 4. Ba-boom, ba-boom. All right, moving on to C. As we take a look at C, you'll notice that this one does not have a constant term on it. So the way that we approach this is going to be a little bit different. On C, instead of factoring a trinomial, what you want to do is look for a greatest common factor between these two terms. They have a numeral greatest common factor, which would be 3. You can take a 3 out of 15. You can take a 3 out of 12. So I'm going to factor out a 3. They also both have one x to give. So I'm going to factor out a 3x, which is going to leave us with 5x minus 4. 3x multiplies 5x to give us the 15x squared. 3x multiplies negative 4 to give us the negative 12x equals 0. Right, so now I'm going to take both of these terms, set them equal to 0. So 3x is 0, and then 5x minus 4 is 0. We simplify both of those. We get x is 0 right here, and we get x is equal to 4 over 5 right here. Those are our solutions. I want to remind you that if you're not sure if your factoring is right, one thing you can always do is use Desmos. Here's what I mean by that. You can type the original equation in, and then you can type in the factored form. So in the case of our problem, we had a 15x squared minus 12x. Let's see, where are our solutions for this guy? Okay, there they are. There's our two solutions. And then below you can type in our factored form, which was 3x multiplied by 5x minus 4. And the two graphs should fit together like a glove. Beautiful. Let's keep rocking and rolling. Taking a look at D. D is the first problem where our quadratic is not set equal to 0. So what we're going to have to do is move everything over to one side. Now, if I can make a recommendation to you, there's always going to be an x squared term, And wherever that x squared term is, keep it positive. So while we could technically move this 2x squared by subtracting it to the other side, that would make the x squared term negative, and we don't want that. So instead, we're going to add 11x to both sides. We're going to add 15 to both sides. That's going to give us 2x squared plus 11x plus 15 is equal to 0. Now it is factor time. 2x squared gives us a 2x and an x. The 15 could be a 1 and a 15, or it could be a 3 and a 5. I always play around with the two numbers that are closer to each other like this first. So like if I put a 5 here and a 3 here, does that work? No. What if I put a 5 here and a 3 here? All right. 5, 3, add. Sure enough, this gives us 6x. This gives us 5x. There's our 11x. All right. So if we set this term equal to 0, we're going to get x is negative 5 over 2. If we set this term equal to 0, we're going to get that x is negative 3. There's our solutions. Moving along, E is similar to the last problem in that it's not set equal to 0. This time the squared term is on the right side of the equation. So I am going to subtract the 6t from both sides. So let's see, what is that going to give us? On this side, 0 is equal to 9t squared minus 6t plus 1. We factor. Now, this one's kind of interesting because our leading term is a 9. And so we've got a couple options. We could do 9 and 1. Or we could do 3 and 3. Again, I'm a big fan of starting with the two numbers that are closer to each other. So let's start with 3t and 3t. Oh, and I can actually see that if I take this 1 and I break it up into negative 1 and negative 1, that will work because our outer terms are negative 3t and negative 3t, which gives us negative 6t. Now you notice that if I set this first term equal to 0, I will get t equals 1/3. Whereas if I set the second term equal to 0, I get t is equal to 1/3. Now it doesn't make a whole lot of sense to say that our answers are 1/3 and 1/3. So only write your answer once. That's it right there. In fact, if we were to take this and graph it using Desmos, I'm going to graph the 9t squared minus 6t plus 1. Watch what happens. We can't put a t in here, so I'm going to use x. 9x squared minus 6x plus 1. You'll notice that it hits the x-axis exactly once, and that instant is at 0.3333 or 1/3. Moving along, we get to the next one, to F. And I'm actually going to start off by making a mistake on this one. A really common thing that I see students do is they see something that has x's here and x's here, and they're tempted to divide. So they'll do something like this. I'm going to divide by 25x. I'm going to divide by 25x, which leaves us with a 1 on this side. And on this side, we get 4x, which would lead us to the conclusion that x is equal to a quarter. Now, that is true. A quarter is one of the solutions to this equation. But in the process of dividing by x here, something very sad happened. And that's that we lost one of our answers. And there's only 2 of them. So if you lose half the answers, we're not in good shape. We're shooting 50%. So let's not do this. Instead, what you want to start by doing is the same approach that we had on the last couple of problems, which is move everything to one side, set it equal to 0. I'm moving the 25x because I want to keep the squared term positive. That leaves us with 100x squared minus 25x equals 0. And now we can pull out a greatest common factor. Our greatest common factor would be 25x, which leaves us with a 4x minus 1. Oh, Mr. Klein, I feel you. I get it. This is giving us the x equals 1/4. The same 1/4 that we found over here. But notice that this term right here, if we set that equal to 0, we also get a solution that x could be 0, right? If I plug 0 in there, the whole equation would be 25 times 0 times something is 0. It works. Okay? So moral of the story, don't divide by x, you lose solutions. One more problem. 100b squared is equal to negative 1 minus 25b. So this is another problem where we're going to need to move everything to one side, which leaves us with 100b squared plus 25b plus 1 is 0. And we're looking to factor. And this is kind of a tricky factor because, well, here's what's not tricky. If you look at the last term at the 1, you know that that only multiplies to 1 and 1. So we're cool there. The problem is right here, the 100b squared. We want to pick factors of 100 here and here so that they will add up to 25. So I might start making a list, like 1 and 100, 2 and 50. Those don't add up to 25. Those don't add up to 25. 3 doesn't go in there. 4 and 25 adds up to 29. That's no good. 5 and 20, ding, 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 ding. Those add up to 25. So we're going to put in here 5b, 20b. Your solutions end up being b is equal to negative 1 over 5. B is equal to negative 1 over 20. Okay, that is it for number 3. I'll see you on video number 4.